Hi, now we're ready to solve more complicated circuits. So what we saw before is if you have resistors in series or in parallel, we can combine them and we can figure out the currents everywhere and have all the information about the circuit. But we also know that for some circuits, there's no way to combine anything. For example, this is not, at first doesn't look too complicated, but uh, in that case, there's no, if you can check, you can find no two resistors that are in series. There's no two resistors in the same branch, and there are no two resistors in parallel either. So there's no way to combine anything in this circuit. Another way to make a circuit more complicated is to start working with several batteries. So for example, here, this is a simple circuit that we're going to solve in a few minutes. But this is a case where we have actually three batteries here, this one, and this one. And notice that we saw before that when there's one battery in the circuit, the current always flows away of the positive terminal. So if you just add this battery here, you will see the current flows this way here. But if you look at this battery here, and you see the current flows this way, so if you say that here the current flows this way because of the polarity of the battery, here you say this current flows this way, and you look at this battery here and you see the current flows this way. So this current here, by the time you're back here, it flows to the left now. Clearly, there's no way that all three currents have the correct direction here because you see they all flow into that junction, so there will be charge accumulating there. So we know that there's at least one, maybe two of those directions that are wrong. Now, to figure out what direction the currents are, the correct directions are, it's not obvious. So you can try to look at the values of the voltages and try to guess the answer. But the beauty of the next technique I'm going to show you is that you don't have to guess anything. So you see in a minute why you don't have to worry about trying to figure out in what directions the current flow. Okay, so this is a case where we actually have, it's not even clear what the correct direction of the currents are. So now I'm going to show you a new technique for solving any circuit. So it's very powerful, and you can find everything about the circuit without having to guess anything. And this is called the approach using Kirchhoff's laws to solve circuits. So it's based on two principles that you already have seen. So there's nothing new in terms of principle. What is new is how to apply them in solving circuits. The first principle you know is this. At any junction, we must have the sum of the currents entering must be equal to the sum of the currents coming out. Okay, and that's due to conservation of charge and the fact that charges are never created or destroyed. So we've seen that before, and we see now how this principle can be used to solving arbitrary circuits. The second principle, or the second law, Kirchhoff law, is also something you've seen. That if you follow any closed loop in a circuit, the sum of the potential differences, which is the same thing as the voltages, as you go around the closed loop, the sum of the potential differences must be equal to zero. That just means that by the time you come back to the initial point, you're back at the same potential that you started with. Okay, it turns out that those two principles, they're called also laws, Kirchhoff laws. This one, the junction rule for currents, and the loop rule for voltages. Those two rules are powerful enough to help us solve any circuit. So how does that work? Okay, let's go back to the circuit. So we're going to focus on an example. To make things clear, it's better to just work right away with a specific example. There are several steps. There will be really six steps. The first step when you have a circuit is first you check if there are any resistors that you can combine in series or in parallel. You should always do that because you want to simplify the circuit as much as possible before you apply the Kirchhoff laws. Okay, so you should always check that. You don't have to, but you'll see why a bit later that if you don't do that, you can still solve, but the solution will become much more complicated to do. So first you check, do you see any two resistors in series in this circuit? Are there any two resistors in the same branch? The answer is no. So we cannot combine any of those three resistors in series. Then you check, are there any of them in parallel? At first sight, some people might be tempted to say R2 and R1 are in parallel, but they're not, right? Because if I draw a closed loop that contains R1 and R2, I also contain the batteries with EMF E1 and E2, E3. So those two resistors are not in parallel, and it turns out here that there's no resistor in parallel either. So there's no resistors in series or in parallel. We cannot simplify the circuit by combining resistors. Okay, so that's the first step. Here we could not do anything. If we could have combined, we would have done so to simplify the circuit. Okay, so we're stuck. We cannot combine series or parallel. What do we do next? That brings us to the second step. The second step is you identify how many branches there are in the circuit, okay? And you know that there's one different current in every branch, so then you assign a current to each of them. You give the currents names. Usually we use I1, I2, I3, and so on for all the branches. And for each branch, you assign a current and you assign a direction. Now, what does it look like? Well, before saying that, when you assign the direction of the current, you can pick any direction you want. You do not have, and it's very important, you don't have to try to guess what must be the correct direction. You pick any direction you want for the currents. You'll tell me that's crazy because if I do any direction I want, it might be that some of them would be wrong, and that's true. You might get some wrong, but what you'll see is that at the end of the technique, when we solve everything, at the end the solution will tell us if we had picked a wrong direction. Okay, so at that stage, you pick direction in each branch for the currents, and you pick anything you want. So how does that look like? So here, first, how many branches are there? It should be clear. You should know now that it should be clear to you that there are three branches. So there is this branch here, the left branch, going from there all the way to here. That's one branch. Then the second branch is from there to there. And the third branch is the right branch from here to here. So there are three branches, therefore there are three currents in this circuit, one in each branch. So what we'll do is that we're going to assign a current to each branch. So let's call I1 the current in the left branch. When I pick I1, I call it I1. You call it I2, IA, I3, whatever you want. But let's call it I1. And then I assign a direction to I1. The direction I pick is totally up to me. So I'd pick up here. Now, once I've chosen this direction here, then the direction of the current in this branch is completely fixed, right? This current goes here, up here, so therefore it must be going to the left here, up through the resistor, and to the right here. So now I have fixed completely the current in that branch. Now we go to the second branch, this one here, and we call the current in that branch I2, and the direction of I2, again, when you get to the point of choosing a direction, you pick anything you want. So I have two choices, right? In this branch, I2 can go either up or down. I don't have to guess. I pick one, anything you want. So let me choose up. Okay. Then finally, we have a current in this branch that we'll call I3. And I3 here, at that point here, can be flowing either to the left or to the right. I'll choose, totally arbitrary, I'll choose to the right. Now, notice, again, I want to emphasize, when you pick a direction of the current, it's arbitrary. Right away here, if you pay attention a little bit, you can tell that there's no way my three guesses for the directions can be all correct, right? Because if they're correct, what? Look at this junction here. I1 is flowing out, I2 is flowing out, and I3 is also flowing out. So that's impossible. You cannot have just currents flowing out of a junction. So I know that my guess for at least one of them, maybe two of them, are wrong. But that's okay. It doesn't matter at this stage. You don't have to check anything. Pick direction you want. What we'll say is that when we solve at the end the equations, the solution will tell us if our directions are correct or not. And what will happen is this: when we solve at the end for I1, I2, I3, when we find the values of I1, I2, I3, If we get a negative value for one of the current, it tells us that the direction that we had picked for the direction we had picked for that current was wrong. For example, when at the end, if I solve and I find that I2 comes out to be minus 2 amps, that will tell me that my guess of direction here was wrong. If I find I1 to be 3 amps, let's say positive 3, then I know that this direction is correct. If I find I3 to be negative, I will know that this direction was wrong. So the equation, the solution will tell us if our directions were correct. Third step, once we've picked the direction of the currents, now we're going to assign polarities to all the batteries and resistors. By polarity, I mean which side is higher potential, which side is at lower potential. In the case of the resistors, we must use the direction of the currents we just picked. Okay, let me go back to this. So here are all three currents, I3, I2, I1. Now I'm going to assign polarities to everything. For the batteries here, the three batteries, the symbol here tells us which side is higher potential. So if you look at this, the first battery here, I know this is higher potential than this side here. So this is the positive polarity, negative polarity. All that is telling us that this point is at a higher potential than this point. Okay, same thing for this battery here. This battery here. This is higher potential and this is lower potential. And for this battery here, this is higher potential on this side, this is lower potential. Okay, batteries are easy. Now look at the resistors. Remember the rule. Now we use the currents we just picked. Once you have a current, you use the current you picked in the previous step. A current always enters the side at higher potential, the side of a resistor at higher potential. So if you look at this resistor here, our I3 is going to the right. So this is higher potential than this side. So this is plus and minus. Okay. Now you look at this resistor, I1 is going up. So this is higher potential and this side here is lower potential. Okay. And finally, this resistor here, I'm entering this side. So this is positive terminal and this is the negative terminal on this side. Okay. So I've assigned polarities to everything. For the batteries, the polarities are fixed by the way they're drawn. For the resistors, the polarities are fixed by the choices of currents we had chosen in the previous steps. Okay, now that we've assigned polarities everywhere and currents, we're ready to actually solve the circuit. So the next step is that we have to set up equations. We have, what are our unknowns? I1, I2, I3. So we have three unknowns. We're going to need to set up three equations for three unknowns, and then we'll solve. Okay, and we'll do that in the next video. Thank you.